Typing in sensitive information and didn't want it recorded.
Okay, we're recording. Welcome to the September 13th, 2017 SIG API Machinery meeting. I think we have a pretty full agenda, so we'll get started. Maybe just briefly, I will introduce the people in the room since there's some new faces and there's even some people off camera. Off camera, we have Joe. Yeah, there's Joe. Joe Betts, who's been working on etcd with us and other things. We have Walter, Matt, Chow, Howie, and Jenny are new additions to our team here. And I'm Daniel. Hi, Lava Lamp. And behind the camera is Jago. Okay, that's who is sitting in this room since David asked.
Thanks. Hey guys.
Okay, let's see. Does someone want to share their screen, or should I find the notes again? Okay, here's the notes. Let's make that a little bigger. Oh, should I share my screen? Share screen. Okay. Yeah, I'm sharing notes. Okay. Should we start with the potentially controversial stuff right away, or go through the fluff first?
I would have.
Let's open with the hard stuff.
Okay.
So I have something that is not controversial. Just want to ask everybody if we have any big breaking change that would be a risk for the releasing, because it came up in the release SIG meeting. We had one last release that was API repo. Just want to ask if we have something like that this release.
All right, I see you added that at the end of the list. That's good. We'll get to that when we get to it. If anyone else has agenda items, please add them at the list, or tell us when we get there. Okay, so the first thing on the list, I've been doing some thinking, we've been doing some thinking, and I'm tired of having the specter of alternative storage implementations hanging over our head. And I'd like to suggest that we just take an official position that we're going to stick with etcd3 for the foreseeable future. And anyone who needs to write to an alternative storage destination, the way that I'm going to recommend they do that is they fork etcd, keep the public interface, and re-implement everything and make it into a shim into whatever service you want to talk to.
So
this makes it clear that the maintenance burden of that is 100% on whoever is doing that.
So I think that when you look at the second item on your list, we are already considering adding more storage interfaces. And we should probably consider how we would like to do that before we go and say we aren't going to have any new storage backends.
Well, I mean, I think whatever we do for the second option, so the second item on the list is what should we do? We need to come up with some recommendation for people doing aggregated API servers. How are they supposed to store their stuff? We need a solution for them. I think whatever solution we adopt for people, if they're talking to like API server and we end up storing an etcd, that's fine. I think.
Would we be happy with forking etcd ourselves and using that to create the interface to our blob API? And I think that that's the sort of question we need to ask, because the thing that we create for our storage should probably move us in the direction of allowing someone out of tree to do something reasonable, like we've done with other webhooks in the product and other pluggable mechanisms.
I think that the tough part is the maintenance burden. And I think that's what bullet point 1 is trying to address, is limiting the scope of the maintenance burden to etcd and not etcd plus whatever else comes along.
Right, but I'm imagining myself later in a month having an argument where I want to add blob storage. And I have to say, well, no, we aren't going to add blob storage. What you're going to have to do is fork etcd and use that API as a backend. And
Hey, David,
Why
why
I
fork?
don't understand why we would be in that situation.
So a CRD, not a CRD, an aggregated API server is running presumably the generic REST storage, which takes a storage interface, and we're wanting to back that with something, right? We could back it with etcd. It could run its own etcd. It could run against the same etcd that the main API server is, or we could back it with a purpose-built blob store type of API implemented that would implement the storage interface, right? And
No, so like if we provided a blob store API, we would also provide a shims so that you can connect your aggregated API server to the blob store API. But I don't know if that has much to do with the existing storage interface.
I wouldn't want us to have to maintain 2 storage interfaces and 2 generic REST storages. That seems worse than the disease.
I mean, think of some things that we want to eventually do with our storage. Like, we would like to store objects by UID instead of by name and keep an index by name. And etcd3 has the features necessary to do that, to keep an index up to date as we update objects.
Yeah, I don't disagree, but I would want all aggregated servers to have the same capabilities. And that means
Right.
those capabilities need to be reflected in our storage interface and any implementations that back our storage interface.
I don't see why we have to take an official stance if people really want to do something. I don't.
Well, it's about
Supports
entry
it.
maintenance burden. I agree with Daniels that we don't want entry implementations targeting specific vendors. I instead of saying no new entry implementations, I would rather see something that says additional entry implementations will be external extension focused. So it would be defining an API that you could integrate with, and we could use it for a blob store. Some other vendor could serve that API from their bespoke storage solution. I don't want 20 different entry implementations against random backends. But I think it's useful to have an externalized entry implementation.
So, and basically I'm saying I want so it's impossible to do what you're suggesting right now because you have to compile something into API server to get it to talk to an external storage thing, right? You have to compile in a replacement for the storage interface.
A second implementation that would speak to an API we would define. And in the absence of that, our external API is the etcd3 wire format, which I think is someone could do that today, and that's basically saying we're not going to support you. You maintain this yourself, but
Yes.
We're going to want to provide that. Your second point is a blob store API as a potential solution, and it would have to be implemented. It would be an implementation for the storage interface. And so if we're defining that API, why wouldn't we also let people who want to provide their own storage implementations implement that API?
So what I want to do is expand the storage interface to include all of the features of etcd3, the ones that we want to use at least. And I don't want to be in a situation where every time we expand the storage interface, we break a bunch of storage implementations. So I sort of want to draw the boundary at the between processes and say our storage API that we expect to write code against is the etcd3 API.
If that's the case, then it sounds like you would want to develop your blob store to implement the etcd3 API. Am I understanding that correctly?
I'm not convinced that we can't write a blob store that stores in etcd.
Okay, so that's the problem, right? Because if you try to do it any other way that doesn't create an external API or use the etcd3 wire format, you are special casing your own special in-tree implementation, and that doesn't seem like a good idea.
I don't expect to have a special case. I'm not quite. We may not be thinking of the same design for a blob store, so I'm not sure. Like, why
Well,
can't
there's
we?
really one spot to put it, right? We have a storage interface, and it's in the package storage, and it is what backs the generic store. If you put it any other place, you would end up trying to either re-implement a generic store or re-implement the finalizer logic.
So
base a host.
I guess the way I see this evolving is user-supplied API servers don't talk to etcd at all. They talk to a storage API that the main API server serves.
And I'm fine with that, but I think that it should be using the API server pieces that we have already built, in particular our generic storage.
Yeah.
That actually follows the same pattern we've done at other things, right? The same mechanism that we use to delegate authentication and authorization checks from the kubelet to the API server can be used by the API server to delegate those same checks out to some other solution.
Yeah, so
in the same way, if an extension server delegates storage to the API server, I would expect the API server to be able to delegate storage to something else in exactly the same
we're
way.
actually in violent agreement. I was not trying to say that we shouldn't write a shim that lets user API servers use an API that we write to provide storage. That was not the point of this item.
So that API, that would be a shim that would it would be an implementation of storage interface in terms of a client to this API, right?
Yes, but
Hey, Daniel, I'm guessing maybe this clarification might help. So the first bullet is really saying that we only really want to store in etcd, and we don't want to support storing in Postgres or MySQL when it comes to the generic store implementation. But as far as the second bullet point goes, we can and probably should have a little shim that conforms to the storage interface that we currently have, so that a user API server can be configured to use that shim to talk over an API that we define that goes into a blob store API in the main API server that then stores in etcd and etcd only, right?
yes, that's basically what I'm trying to say.
But the API we define, the surface area of that is to provide what the storage interface currently uses is one set of features. To provide what has been kind of said, we want to use more features of etcd. Like, as you expand the storage interface, that API has to expand. And
so let me talk a little bit more about the storage solution that I think we should build. I'm not sure if it makes sense for user API servers to worry about indexes and building storing objects by UID or by name. Since
are those things that the generic REST storage would expect to have available to it?
What I'm saying is, like, I think we need somewhere a layer that talks to etcd3 that can build indexes and maintain them. We can do things like split spec and status. But I'm not sure we need to expose that complexity to user written APIs. Like, I would expect when a user API server goes ahead and does a write operation, I'd expect that data to come into the blob store interface. The blob store interface, maybe it has a spot for, this is the spec blob, this is the metadata blob, this is the status blob, or maybe something of that nature. At least splitting the metadata and the other stuff, and I would expect it to maintain, like, abstract away the maintenance of the indexes. So hopefully what I'm saying is the current form of the storage interface is maybe not the ideal form that we want to end up with.
I don't want to have my aggregated API server storage end up different than the API storage currently used by the Kube API server. Right now, they're identical. And that gives us a lot of reliability that if we were to change that, we would lose. And
so if we, to be clear, if we were to change this, we would also change the existing, like we only want to write the logic to use to maintain the indexes in one place, and we want everything else to use that logic.
Can I step into this conversation? I feel like you guys are kind of going back and forth on the fact that these two bullet points happen to be adjacent to one another. And just let me finish. I feel like we can agree on one thing for a moment. I would like to take a step back. Is there anyone on this call who suggests that we really need to have an option besides etcd3 as the underlying storage system in Kubernetes? If there is such a person, let's talk about it.
I think that if we are going to write something different for aggregated API servers, that different thing that we write should be fully valid to use for the Kube API server, because the Kube API server is nothing but a single API server, just like any other.
Right, but let's pretend that we live in a world with only one API server for the purposes of question one, which is, does anybody advocate for a different backend than etcd3? I think all we're trying to say is, let's scope it down to etcd3.
So let me jump in here, right? So we are dialing in from Amazon here, and we'd really like to see a support for DynamoDB added as well, right? We completely understand the maintenance burden aspect of it, but you have a really good example.
Can you get closer to your mic? Sorry, we're having a hard time hearing you.
Okay. So, I mean, we completely understand the maintenance burden of supporting another data store, right? But you have a really good counterexample in the networking SIG, right? So the entire ecosystem is vibrant because of the various networking components that are out there, right? And they've made that possible. Why is it that that the community has to take a hard stance on supporting only one particular data store?
Right, and the networking team does that with a CNI plugin, right?
Right.
Right. So I think the comparable thing here would be to describe the interface the remotable interface that an external storage provider, including the one that we build for aggregated API servers, would be expected to fulfill.
So
at least that, and maybe even a loadable plugin mechanism for data stores, right? And you don't have to have, right? So that's another suggestion, right?
I think this one is tricky because portability is one of the critical benefits of using Kubernetes at all. And so API server needs to work in the situations where it's not on a cloud. You can't use a managed service like Dynamo or Cloud SQL. And we need to be able to test and verify that the behavior is consistent across different deployment environments.
Yeah, I think if somebody swaps out the storage, like you invalidate all of the performance work, like you'd have to independently retest it.
I'm not saying that we retest it for them. I am saying that if you build a remotable interface, and if we then use that remotable interface for our aggregated API servers, then we will have a very high degree of confidence that it works. And if somebody chooses to plug in on the back end, it will end up being a plugin external out of tree, just like we have for volumes and for networking and for.
I do think there's a fundamental difference, though. The plugin changes for volumes and networking are about the functionality of the cluster that is exposed to the user. This is the storage backend, and to a certain extent, the user shouldn't know if it's Berkeley DB or etcd3 or anything else.
Yeah.
So
this is really
we have a choice to invest in this or not, but the user doesn't really get any particular benefit whether we choose one or the other. It's only what we pay for the flexibility to use and different implementations.
Yeah, this is really not this is an implementation detail, like where API server chooses to store its stuff, and I think commonality between clusters is only going to be a good thing for system administrators. Like if you learn how to care and feed for one Kubernetes cluster, that knowledge is portable. Doing surgery and swapping out the storage backend is actually a pretty big deal. And I
for the system data, at least.
I mean, you can switch out between etcd2 and etcd3 today. I mean, it's it's cleanly separated today, and I don't think we should give that up, especially when the need to externalize storage for aggregated or extension servers is present. Like you say, there's no benefit to users, but if I'm running an extension server, having this API defined and usable by any API server gives me immediate benefit because I can run my server and hook into storage. Like defining the API and writing an implementation of storage that uses that API provides benefit.
But why does the extension API server care? I mean, if this is all hidden in a library, it just says store this and it gets stored. The fact that it's etcd3 or it's a plugin is irrelevant to an extension API server.
No, defining the API means that I can run my extension server against any kube server and have confidence that whatever the backing mechanism is, my extension server will run.
I don't understand.
Yeah, I don't understand how that follows from your premise.
I have an aggregated server that I want to be able to deploy to any Kubernetes cluster.
Yep.
Right.
That means that it needs storage.
Sure. And
I would like to not worry about what storage that Kubernetes cluster is using.
There's an API. The storage behind that API should be irrelevant to you.
I agree.
So then we don't. So it doesn't matter what the storage is to the extension API server.
I think we're agreeing. I would like an API defined and a storage implementation that uses that API that aggregated servers can use and that the core API server can use.
So let me take another approach, right? Like the point of an API is to give some isolation is to define the interface, right? You give some isolation between the consumer of a service and the provider of a service. Right now we have in code a interface that does not cross process boundaries, right? The storage interface is a Go concept. It is not a API. It is not like an inter-process API. We have external to our code, like actual process boundary crosses can happen in either etcd2 format or etcd3 format. Mm-hmm. I am proposing that we say we're going to stick to the etcd3 format in terms of process crossing. I think we need a solution that is like, we don't want to talk etcd3 protocol between user API servers and the main API server. That would be kind of silly and doesn't solve our problem.
No, that wouldn't
we
be
want to do
silly.
quota checking and let me finish. We want to do quota checking and maybe auth ACL checking at that layer, so it doesn't really look like the etcd3 protocol. And so basically our choices are to stick with etcd3 or develop a new inter-process API. And I'm suggesting that our energy is better spent sticking in etcd3 and taking advantage of its features rather than inventing a new API that we're going to live with. Because if we write an API and people make a bunch of storage implementations of it that aren't etcd3, and we add a feature or we want to roll out like indexes or something like that, our hands are kind of tied because we can't really expand that interface.
Yeah, I don't disagree that a storage API is not something we should do lightly. But if we're not going to define a storage API, then I think extension API servers should use etcd. I don't think we should come up with something other than etcd and other than a generic storage API specifically for aggregated servers.
I don't know if I followed that. I think it is super important in the very near term for us to come up with a solution for the problem of where do aggregated API servers store their stuff. To me, that's really a separate question from
because they're all API servers, right? Like if they're all trying to store and they're all based on the same generic API server, then the API that you're using to store the data for an aggregated API server should be the same as the one that you are using for a Kube API server. And if we want to add to that to be able to support a blob store, by all means, that's fine. But it also means that my Kube API server should be able to support running against whatever this new API for storage is going to be. And that means that we end up supporting that API, and it means that someone could reasonably plug into it and use it. Because
the reasons you gave, Daniel, about like if we add indexing or we add new features and we have to expand the API, that's true, but that's equally true for the generic REST storages running inside aggregated servers expecting to be able to use those features. And
so the API that I want between the aggregated API server and the like main API server, I wanted to abstract that away. So like we add indexing, you should not have to recompile your extension API server to take advantage of that. It should just be the case that all of your queries suddenly are faster.
Then if it's hidden behind the storage interface, then it doesn't need to be in the API. That can be in the storage implementation.
Okay, so I think I need to outline, like, write a document that gives what I'm thinking the storage API should contain, and so why that is a different level than this.
So like for the second point, like right now, aggregated servers basically can use etcd, and they can use their own etcd via an etcd operator or something, or they can be given access and credentials to use the same etcd as the main API server, and you just trust that they, put their stuff under a different prefix or key space.
And
either of those work technically. One is easier to back up. One is more isolated. I think we should document both. And but before we go do something like a blob store, I would expect any third options, any non-etcd options, to be equally usable by the main API server.
So I don't think
and in the process, we would be defining an API that someone who wanted to provide a non-etcd storage mechanism could write to and implement.
I think there is a cost to abstraction, and just seeing the difficulty with which we've moved from etcd 2 to 3, or are moving from 2 to 3, demonstrates some of the challenge in migrations.
I don't disagree. I don't think we should do it lightly, but I don't think we should special case aggregated servers. I would actually be okay documenting how to use standalone etcd or shared etcd and saying that's all you can do right now.
I think the mental model of seeing Kube API server as just another API server is a useful thought exercise in any design process. So I think that's a good perspective. I think certainly I've been thinking of it as system data is somewhat different than user-generated data. And I think the system should continue to function even if the user works themselves. So maybe this is also true of Kube API server. Maybe if it is borked, something else needs to continue to work. So I think that's a useful thought exercise.
For the first point, I will say, I think that I would agree that we shouldn't add more in-tree storage implementations for specific backends or vendors. If we add more in-tree storage implementations, they should be external focused, extension focused, like the network CNI plugin stuff and the volume CSI plugin.
I do agree that makes sense.
Going once, going twice.
No more in-tree storage implementations targeting specific vendors.
So are we going to? I feel like there's a lot of supporting motivation that really wasn't maybe properly discussed at the beginning of this, and also I think somebody needs to round up everybody's objections and see if we can resolve all or most of them. Is that Daniel's AI or somebody else's?
And I think the major open question that causes angst is, what is the solution to aggregated API storage? And having that conversation here and trying to design that solution in this venue is probably not the right way to do it. So
yeah,
I think
the interested parties around designing an API for that are people wanting to run aggregated storage and delegate that to the main API server without giving them direct access to etcd, and also alternate storage vendors who want to provide their own storage. So like there's interest from both sides, but at the same time, there is a cost to abstraction and designing and maintaining over the long haul that API is going to be expensive. And so we have to be careful about how we do it. It doesn't mean we can't do it, but we shouldn't rush to do it and assume we can do something quickly and then change it later willy-nilly. Like once you have an API out there that is storage-based, it's really painful to move that.
So going back to your earlier point, Jordan, yeah, I agree. If we define a bulk API and the user API servers are using it and somebody else writes a re-implementation of that bulk API, then they can use it. Yeah, sure.
They could use it to back their Kube API server, the core API.
Yeah,
The core API server is just a bunch of REST storage. So if REST storage can use this interface in an aggregated server, it should be usable in the main server. Like it's the same storage.
So I think it's complicated by the Kube API server both having it's like got the storage egress in it as well as the REST code. So yeah.
Maybe the distinction we're looking to make here is technically, obviously, it should work. Like the Lego bits are designed to plug into each other, but would we encourage that? And do we have any particular motivation as a project to make that work? I think we're kind of arguing that we have motivation in this project to say that we would like the Kube API server's backing store to basically always be etcd3, because that allows us to invest in its reliability and take advantage of its features and sort of like not invest in a bunch of other places.
I'm just trying to think through bug issues filed against API Machinery and a new question in the bug report of what backing storage are you using and
now
trying to reproduce it.
I don't think you get away from it. It's the same issue you have with networking and volume plugins. If you define an API, you support the API up to the point of the call, right? And so, and the point earlier about like if you plug in something that doesn't work well, yeah, the same thing happens with networking. And so part of the must gather is what storage are you using? And we validate with etcd, and we validate this hypothetical API, we would validate it by means of aggregated servers running against the main API server. So we test it from both sides, but your storage implementation owns your storage. And so.
All right.
Tim, in the chat, can you clarify what you agreed so vehemently with?
It was the thing that we wrote.
Okay.
We wrote.
Yeah. It's hard for future civilization.
We are 40 minutes in. I think we should table this issue for the moment, and I will write something up concrete for us to argue about at the next one. Does that sound okay?
Yep.
That was fun.
Okay, next item on the list. It came to our attention that the current upgrade storage object scripts is very crufty, broken, and at least some distributors distributions are not actually, in fact, running it between upgrades or after an upgrade. So I think we as a SIG need to come up with a solution that just works. Anyone disagree with this being an item of some importance?
I'm really interested.
Okay.
It's very important. I would like to see it be able to be run separately and not automatically run internally. The idea that you upgrade and a cluster like starts rewriting, migrating stuff scares me.
A very rough sketch of what I'm thinking here is like the API servers have a consensus mechanism where they produce the desired version of the cluster because it could be more than one API server, and if you do a rolling upgrade, they might not all be the same version. So there has to be some like desired version, and then I think there should be a controller, which could be built into the controller manager or could be a separate binary that runs constantly, monitors the stores state as to when it has last run the upgrade or downgrade functionality, and watches the desired and state and runs it as necessary.
Yeah, if you build it separately, you can run it as a job, you can run it as a pre-upgrade job, you can run it as a post-upgrade job, you can run it continuously in a controller, but
right.
Yeah.
I saw Clayton on the thread. Did he talk about the OpenShift migrate command that we use to do this?
Yeah, he called it out.
Yeah, Clayton mentioned it, and it doesn't sound like a great solution to me. So
The nice thing is a lot of the
One product rolls gracefully.
systems that we can leverage some of their learnings.
yeah. Okay, so it seems like we have general agreement that it's important and the sort of very rough outline of how we should solve it. Okay. The next item is informational. I signed us up for a deep dive at KubeCon in December. I have no idea what I signed us up for, but we're signed up for it. Yes. Okay, Joe, you want to talk about?
Yeah, I'll be brief here. I will, if I can, I'll share my screen.
I think I may have to stop sharing mine.
Cool. So we've built a simple command line tool that allows us to well, one of the limitations that we got when we upgraded to a Kubernetes version that stored binary data in etcd was we lost the ability to just go introspect the data as easily as when it was stored in JSON. So, obviously using a binary format is much more efficient and a good thing to do. But we've had some needs to just be able to go in and directly kind of inspect the data that's in etcd. And right now, if you look at it in binary, it's kind of hard to piece together what's going on there.
It might be too small too. I don't know.
Yeah. Let me see if I can.
It should look fine.
Size is fine.
Okay.
Okay. But here's just kind of like a hex dump of what you might get for a pod. You can kind of see some strings in there, and you can kind of make sense of it. But we have the ability to decode this for people. So the idea was just build a simple command line tool that allows you to decode data, encode it back if you really had to, and also be able to extract it out of the DB files in more emergency situations. It's a pretty simple tool. And what it does is it just uses the Kubernetes code to do its work. So if you say, let me grab a simple example here, and then we'll move on. But just show you one really quick. So say we take and we get the value of a pod, and we want to get that back as JSON. You could just pipe that through the tool, and well, that was YAML. But you get the idea. It just does the decoding. It just uses the right logic. It first looks at what's in the binary, figures out which metatype it is, applies the right protobuffs to it, and all that. It's a simple tool, but we'd like to get this into Kubernetes Incubator, and the reason I wanted to bring it up in this forum is Kubernetes Incubator projects like to have some cross-organizational involvement. So, I already have a champion for this, and I think, what was the other proper
I think I may be a sponsor.
Yeah, so we've got a champion and a sponsor, but we were hoping it's a very low level of effort here, but if anybody would be interested in being listed as an owner of this tool, you might be involved in some code reviews now and then, stuff like that. It's only 1,000 lines of code. Either speak up now or mail me afterwards, and we'll get you added.
This
might be naive.
Oh, go ahead.
This might be naive, but how is this different than something I could do with kubectl convert? Right, I get bytes, I decode those bytes, I transform them into something else, and I can output it as a particular version.
Does kubectl convert read BoltDB databases?
If you're doing a get, you're getting the proto format, right?
So the distinction is what we store is sometimes different than what you see at the API layer.
But no, what's stored in etcd is always API versioned. You're just seeing protobuf versioned data. But kubectl should be able to speak proto.
kubectl convert ought to.
Yeah, I actually don't like convert, but something that echoes.
I'm not convinced that's a functionality that kubectl should have.
kubectl should be able to read proto and decode to the versioned API object.
Well, so another
interesting
thing that Joe mentioned was that the demo was running against a running etcd, but we can talk directly to the BoltDB as well. It has a mode where if etcd is down, you could still dig around in there. So it's a really great debugging tool for when everything's gone sideways.
And it doesn't introduce a lot of new logic. I mean, this is basically calling into Kubernetes code within a couple lines of code, so it's pretty lightweight, but it's mostly just packaging everything in a nice utility so that anybody that needs to poke around down in these deeper layers has a clear way to do it.
The point of this is as a toolkit for the system administrator when the cluster, something has gone wrong and you need to repair something.
Yeah, I definitely like the idea of something you can pipe data to, either from etcd or from BoltDB or from the API or from anything that can like read proto and read YAML and read JSON. And
this is inspired by Borgmaster, because Borgmaster used its own custom like checkpoint format, and we had to build a bunch of tools to recover clusters if something happened.
Yeah, can you not? Is there not a tool that exists to read a specific key out of BoltDB?
The thing is this.
The BoltDB key is really hard to figure out because it's not the etcd key that you see when Kubernetes calls it API server. etcd stores these kind of obfuscated keys that it uses to maintain its indexes and version history. So this tool will actually go through etcd or go through BoltDB and find your etcd key for you and all the versions that it exists at. You can actually go look at historical versions that you might not otherwise be able to see.
I'm also not
with my one thing well hat on. Like I like the idea of getting the data however you get it, then piping it to it, but instead of like building and reaching out to random, not random, but like lots of different things from one tool. But that's interesting.
Yeah, I'm also not sure how battle hardened the BoltDB command line tool is. I used it once and I found a pretty major bug in it. So
yeah, it's
you said get, but we did delete. No.
Yeah, and there are cases where sometimes you do have to like use the BoltDB and then you find a page, but then you want to pipe the page binary out. You can pipe through this and figure out what you're actually looking at in that page. So there are some more advanced workflows you can use this tool for, and we've done some of those. The most straightforward is just to literally pipe something out of an etcd read and get it back.
Yeah, it just surprised me that kube control, it wasn't like a get the data, pipe to kube control and call it a day.
Yeah, I mean, usually if you have the API server running, you wouldn't necessarily need this. This is kind of more for deep diving.
Okay, thanks, Joe. Mehdi asks a question about risk. Do we have any big changes like the one where we split out the API types last time? I don't think we do.
Nothing I know of.
Yeah, I don't think so.
Okay.
So I just want to say that I'm sorry I spoke out of order at the beginning of the meeting. I heard the question of ordering in agenda came up, so that's why I thought this is potentially a release issue, and I think should have priority. I do believe, however, that we should move controversial topics to the end of the meeting, so we can get rid of these small tasks. We don't get tired of those controversial things, and we don't get to these smaller ones.
Yeah, sorry. I'm used to like Robert's rules where you add the new business comes in and you put it at the end of the.
No, I agree with that. But what I'm saying is that controversial issues better to be discussed after everything else.
Then you're not so grumpy.
I don't know. I think that position is kind of controversial.
Yeah.
Yes.
Cole, do you want to say something about CRDs?
Yeah, sure. I just wanted to say, hey, I'm Cole Mickens. Recently started working for CoreOS. I have some availability in the 1.9 process. I'd love to pick up some things from API Machinery. In particular, we're interested in CRD sub-resources, JSON schema for CRD resources, and garbage collection. I'm starting to troll through GitHub issues and the past notes for this SIG, but if anyone has any pointers on that or knows of work items that I could pick up, that would be really great.
I would quit with Nikita and Stefan. They've both been working on it, and as I recall, does that echo me? The validation stuff just landed, and she has a proposal for sub-resources that may or may not have already merged, but it was definitely out for review.
Okay, and what was the alias for that person?
Nikita and Stitz. Stefan is STTTS. Palindrome. I really like it.
Yeah.
Okay.
You'll get you every time. Welcome.
Thank you.
Thanks. Okay. Let's call it a day. Thanks, everyone.
Thank you.
Thanks, everybody.